Hello and welcome to my video lesson 3.1 on the vertex form. So we're looking at quadratic functions, that's the name of the unit, and in this one we're specifically looking at transformations or the vertex form, which is going to be what we're going to look at in a second. So the simplest quadratic is y equals x squared, but the best way to think about it is anything with a degree of 2 is a quadratic. So a linear equation has a degree of 1. So this is the classic y equals mx plus b, whereas a quadratic is a degree of 2. So it's going to have an x squared instead of a x to the 1 in this case. Okay, so that's kind of the difference between quadratics and linear equations, which is probably what you focused on mostly for the last 4-ish years. Definitely, I think you see linear equations definitely in grade 9, maybe even in grade 8. And then all the way up till now. Now we're looking at quadratic functions. So the standard form that you see it when you factor is like this. So if we factor a quadratic to find the value of x, that would be one way we would probably see it. But the most useful form in terms of actually getting data out of the equation or making a graph out of the equation is the vertex form. So this is what we're going to look at today. Alright, so using the vertex form we can say a lot of things, including the vertex, a lot of things about our function including the vertex, direction of opening, translations, domain, range, min, max, and stretches. 4 things to look at most closely. The value of p is the direction and the magnitude of the horizontal shift. Notice that the negative flips the p. So if you look at the vertex form, maybe I'll write it again here so it's nice and big and closer to our actual graphs, so we can scroll down a little bit. Okay, but it flips p, which means, so right here, p is being flipped because of the negative in the vertex form. So if you see a negative, it's probably actually a positive p. Okay, so just think about that, which is kind of confusing, but anyways. And q is the direction and magnitude of vertical shift or y value shift or translation. Sign on a, so if this is a negative or positive, it's going to make a big difference. It tells us the direction of the opening. And then the value of a, if it's a small fraction less than 1, then it's the y values are decreasing, okay, or it's a vertical compression, I guess you could say. And if this is a number bigger than 1, then it's a vertical expansion or stretch. Okay, so that's the overview. Let's take a look at our most basic graph or basic quadratic. It would look something like this. It's not going to look exactly like this, but something like this, where the vertex is down here at the point 0, 0. The vertex is the key of what we're going to be looking at most of the time when it comes to quadratics. There are other important things, but that is one of the big items we want to take a look at. Not perfectly drawn, but it's fine. Okay, the second graph here that we're looking at has a negative a, or negative x, right? So the a is a negative 1 in this case. So what are we going to get? Well, it's going to flip the direction of our graph. So it's going to look something like this. Something like that. Okay, so vertex was at 0, 0. Vertex is still at 0, 0. There's been no translations, but there has been a flip, a reflection in the x-axis. Okay, going down a little bit lower, now we are adding a value to A. Okay, and this is a value greater than 2, or greater than 1, sorry. So this is going to mean that every y value is bigger than before. So you can kind of imagine it's about half. Yeah, something like that. Okay, it's roughly half the width of the old one. Okay, still has a vertex of 0, 0, which is interesting to note, but it's about half the width of the old one. And this still really bothers me. There, that's a little bit cleaner. Okay, the next one here has it's still positive, so it's still opening upwards, but it's got a and it still doesn't have a translation or a shift, so it's still got a vertex of 0, 0. But instead of being squeezed, it's being expanded by double, basically. So let's go 1, 2, 3, 4, 5. So roughly speaking here, it's not perfect, but roughly that is our new graph. It's basically double the size of the old one in terms of width, or for every y value, it's actually halved now. So that is what would happen for that. For a being a fractional number, a small fraction less than 1, it widens the graph or shrinks the y values. Okay, this next one is where our vertex actually moves. So here we have the q value, if you want to look at our original equation. Okay, a q value of positive 5. So what that means is that we're going to be shifted up. Oh, that's a little bit big, hey? Shifted up. How about I make this a negative value? And then it will make more sense, because then we can deal with it. There you go. That's so much better. Okay, anyways, so it's shifted up by 5, and now we can, because it's negative, it's actually going to go down, right? So a is negative, so it's going to go down. So we're going to have roughly the same size, something like this. It's not perfect, but starting to get the idea here. Okay, roughly speaking like that. Our vertex is at 0, 5. And in this case, our vertex is at 1, 2, 3, 4, 5. But it's negative 5, so 0, negative 5. And it's going in the positive direction. So let's think about it. It's roughly here, roughly here. We're trying to keep it roughly in line with the size of our other graphs. I don't know if I did a fantastic job, but roughly speaking, I think that's close-ish to our other graphs. Okay, and let's zoom in on this one. Here we have our p value is changing, so that will give us a horizontal shift. So let's just look at the p. So we're replacing, so x, we're replacing it with x minus p. So because we're replacing the x, that gives us a horizontal change, or a change along the x-axis. So just keep in mind that in the vertex form we already had a negative. So two negatives make a positive. So this is a positive 1, 2, 3, 4, 5. Okay, this is a positive 5 translation. Okay, and it goes 1, 2, 1, 2, 3, 1, 2, 3, roughly something like this. Wow, my drawings could be better. Close enough. Okay, so it's still opening upwards because there's no negative in front. Okay, and over here we have the opposite. So instead of x minus 5, we have x plus 5. So we're going to go in the other direction. 1, 2, 3, 4, 5. So right here, and we're going to go, whoops. Something like this. Okay, with a, now I don't like to have the graph going past the pictures, so I'm going to get rid of that. Okay, but it looks something like that. And so just looking back at an overview of all of those possible changes, we have a negative, which flips it. We have the a value can give it a stretch vertically, up or down. It's easier actually to think about it horizontally, but it is a vertical stretch. And then we have the q value, which changes the horizontal translation. And we have the p value, which changes the, q value changes the vertical translation, p value changes the horizontal translation. Okay, so I'm going to rewrite that equation out here so that we can keep that in mind while we're doing the next few questions. So just want to double check that the p and the q, I always mix up p and q for some reason. Kind of like the same letter but backwards, or reflected of each other. Reflected in the y-axis. Anyways, all right. So make a graph using the equation below by hand. So if we look at the one on the left, what are we going to do to make this equation? So what we're going to do is we're actually going to start by looking at the vertex. So this is going to tell us the y value of our vertex, and this is going to tell us the x value of our vertex. So we're going to have 4, 1 is our vertex. So 4, 1. Right here is our vertex. Then what do we do? Well, next we're going to have to look here at the 2, the negative 2, and see that it's going down. And so at this point, we know it's going in the general downwards direction. Okay, and then you could try putting in a value for x and see what happens. So I'm going to put in a value of 2 for x and see what happens. So let's just try this and see if we can get something. So what if we put 2 in here? Well, then y would be 2. We would get 8. Oh, negative 8 plus 1. So y would be negative 7. Okay, so if we put a 2 in, we would get negative 7. So that's here, which means that we would get negative 7 here. And so we have a pretty wonky stretched out graph that looks something like this. It's not perfect, but it's probably pretty close. Close enough. Okay, if you don't have numbers on the chart, it's actually a little bit easier because you don't have to worry about it so much. But the most important thing is that you get the direction correct, so the fact that it's opening downwards, and that you get the vertex correct, which is that we have 4, 1. This is very important, and the fact that we're going downwards is very important. Let's just go back to what we had before. So our just a good easy way to remember this is here our a value is positive. So positive makes a smiley face. And if you look at our a with the negative value, you can see that we have a unhappy face. It's a grumpo man, super unhappy. So the frown is upside down. So positive means happy, and negative means sad or down. Okay, let's go back to what we were doing before. So make the graph using the equation below by hand. Go ahead and try out this second equation and graph by yourself. So pause the video now and try it out. Okay, hopefully you've had a chance to do that. Now let's go through it together. So pause it, try it, and then watch what we're going to do together. So here, this tells us that we have a value of 2, and this tells you a value of -5 for our vertex. So 2, -5, that's right down here. So 2, -5, that's our vertex. That's great. That's what we wanted. And this here tells us that we have a positive or a happy direction for our curve. It's curving upwards. Okay, so what can we do here to get to our answer? Well, let's try having x equals 0. Let's see what happens if we do that. So we could at this point just go, and this would be perfectly fine for, whoopsies, wow, that was wonky. For most, what is happening? For most of the time, you could just go like this, and just draw like this, and that's good enough for me, okay? But let's try to be a little bit more careful. And sorry about all that. And what if x equals 0? Then what do we get? So let's just try 1 point and see what we can do there. So if we do that, we're going to notice that we actually get y equals 1/2, and this whole thing goes to -2 squared minus 5. So y equals -2 squared is 4 over 2 minus 5, which is the same thing as writing 2 minus 5, or y equals 3. -3. -3. So if x is 0, y is -3. So let's just, maybe we'll use green for that. Oh my gosh, why is my polymer injection not working very well today? So that is that point there. But you can actually go over and do symmetry, because these graphs are always symmetrical. And so we can have it on the other side as well. Oh my goodness. Okay. Graph on the other side as well. My pen is down. Why is it doing that? So it's going to look something like this. Okay, it's not going to be perfect, and we're not going to bother with the rest of the points, but it's just good to know that you can get some point values like that by plugging in values of x. All right. So one option is the question could ask us on an assignment or a test, make a graph using the equation below. But you could use a graph to find the vertex form of the equation. So it's going back basically completely backwards. So just a reminder, this is our equation that we're working with, minus p plus q. Okay, so with that in mind, we can actually get p and q pretty quickly by just looking at our vertex. Because our vertex will give us, in this case, 4, -2. And so that means that we're going to have, let's use red, that means we're going to have a value of p that is 4 and a value of q that is -2. Okay, fantastic. Two other points we can notice here is 3 and 1 is another point, or this 5 and 1. But let's use 3 and 1. And so what we can do is sub in our values for x and y, because those are x and y values that land on our function. So here we can now solve to find a. So here we're going to have -1. Oh, this should be squared. Whoops. And so when we do that, we get a times 1, and then minus 2, we can actually move it over to the other side, so we're going to get plus 3. And so a is 3. Fantastic. Not quite done yet, though. Now what we want to do is, maybe I'll use orange. Now we want to put a back in place. So 3x minus 4 squared minus 2. And now we have our final equation. Okay, so now's a good time to pause the video, try this next question, and then press play when you're ready. Alright, let's take a look at it together. So first of all, let's find the vertex form. So, the vertex, which would be -2, 3. So that's our vertex, which would mean that we can use, our equation, but let's fill in what we know. So we have a, we have x minus the p, and in this case p is -2, so subtracting a minus, or subtracting a negative, pardon me, is positive, and then plus 3. Okay, and so now what we want to do is solve for a. So what I'm going to do is I'm going to pick a point that's nice and easy. So 0, 2 is nice and easy because one of the values is 0. I love when things are 0. So that one we can use. So let's plug that in and see if we can solve for a. So so x and y. So y is 2, x is 0, plus 2 squared, plus 3. Okay, and then what we can do is simplify some stuff. So 2a, it's going to be 4a because there's a 2 and it's squared, so that's going to be 4 plus 3. So now let's move the 3 over, so it's going to be a -1 for a, and then finally a -1 over 4 is our value for a. So now substituting that back in, we'd have y equals -1 over 4, x plus 2 squared plus 3. And that is our final equation. Okay, so just a reminder about everything that we've done so far today is we've looked at some of the basic graphs and what can change on them based off of the vertex form. And then we looked at graphing by hand from an equation and going from a graph to an equation with algebra. All right. I hope that this video helps you understand vertex form in quadratic functions a little bit better. Good luck!